Okay, so in this week's class, what we're going to do first is I'm going to go through the 3 exam questions that I gave you for homework last week. So make sure that you've completed these questions before you start watching this video. I'm going to go through these solutions and then we're going to finish off the rest of the booklet or the PDF that I got you to download last week. So we're going to look at currency exchange, we're going to look at distance, speed and time, and we're going to look at ratios. Then I'll give you a few more exam questions to practice for next week. Okay, so let's start with 2019 paper 1 question 4. In this question, we're told that Katie's income is €52,460. However, Katie makes an 8.5% of the money she earns is contributed into her pension for when she retires. And Katie doesn't have to pay tax on the money that she contributes into her pension. So 8.5% of this figure is €4,459.10. So I know that before we worry about the tax at all, I can subtract her pension contributions from the amount of money that she earns. The amount of money she earns minus her pension contributions leaves me with $48,090. This is the amount of money that Katie has to pay tax on. So this is her taxable income. This is the figure that we're going to use for part 2 of the question in order to work out how much tax she has to pay and then to work out her net income. Okay, so in part 2 of this question, we're trying to work out Katie's net income. In other words, remember, net is the amount of money you actually take home. So I know that after she's contributed to her pension, she's left with $48,090. And that's the amount of money that she has to pay tax on. In part 2, it tells me that she has to pay 20% tax on the first €34,000 that she earns. So 20% of €34,000 is 6,800. And then on whatever's left, she's going to be paying 40% tax on it. So to work out what's left, it's the amount of money, $48,090 minus 34,000, leaves me with €14,000.90. Remember that this figure and this figure always add up to what you started with. And I know that on this $14,090, she's going to pay 40% tax. 40% of this figure is $5,636. So now I've worked out the 2 different rates of tax, the amount that each one is equivalent to. Now I need to add those 2 figures together. 6,800 plus 5,636 cents leaves me with €12,400.36. This is her gross tax. €12,400.36 is the amount of tax before deductions. But we're told that she has a tax credit of $4,200. So we subtract the tax credit from the gross tax, and that gives us the net tax. The amount of tax that she actually has to pay is €8,200.36. So I know that this was her taxable income, and that's the amount of tax she actually has to pay. So to work out her net income, the amount of money she actually gets to take home, it's $48,090 minus her net tax, the amount of tax she has to pay. That leaves me with €39,800.54. This is the amount of money that Katie would actually get to take home after her income tax has been deducted. Part B here was quite straightforward. In this question, we were told that Katie took out a credit card loan of €420. And that there's the interest rate, that it's compound interest and it's compounded on a monthly basis. And I need to work out how much will she owe after 3 months. So once it refers to compound interest, you know that you should go to page 30 in your maths tables and use the formula for compound interest, F equals P times 1 plus I to the power T. Where P is the initial value, and the initial value of the amount of money she initially borrowed was €420. The interest rate is 2%, and remember that when we're using our I, you get the percentage and divide by 100. The percentage 2% divided by 100 is 0.02. And the number of times that interest is going to be applied, if it's applied every month, then obviously over 3 months it's going to be applied 3 times, so T equals 3. Once I know P, I and T, I can just substrate into the compound interest formula. The final value, or the amount of money she's going to owe after 3 months, will be 420 times 1 plus 0.02 to the power of 3. Now on the right hand side they're all numbers, so you can just plug that straight into your calculator, and I work out that Katie will owe €445.71 after 3 months. Okay, part C again, it's basically, we'll treat this question the exact same as we were treating the questions on VAT last week. In this question, we're told that Katie bought a motorbike 1 year ago, and that since she bought it, it has lost 10% of its value. And the value of it at the moment is €12,150. If it has lost 10% of its value, then obviously it's only now 90% of the original value of the motorbike. So I could say that the value of the motorbike at the moment is equal to 90% of the original value. If I know 90%, I'm going to divide both sides by 90 in order to get 1%. 90 divided by 90 gives me 1. This divided by 90 gives me 135. So I can say that 1% of the original value of the bike was €135. So to work out 100% of the original value, you multiply both sides by 100. Because 1 multiplied by 100 gives you 100%. 135 multiplied by 100 gives you €13,500. So originally the bike must have had a value of €13,500. Okay, let's have a look now at 2018 paper 1 question 10. The first part of this question was very straightforward. We were told that Lorna earns €50,000 gross income. That's the amount she earns before deductions. We're told that she has to pay 20% tax on the first $35,000 that she earns. 20% of 35,000 is 7,000, and she has to pay 40% tax on whatever else she earns. So 50,000 minus 35,000 gives me 15,000. Remember, these two figures have to add up to this one. But I know that means she pays 40% tax on the remaining 15,000, and 40% of 15,000 is €6,000. If I add the 7,000 and the 6,000, I get €13,000. Previously, we've always referred to this as our gross tax. But previously there's always been a tax credit. There's no mention in this question of a tax credit, so we have to just assume that there is no tax credit. So this is actually the amount of tax, the amount of income tax she has to pay. The question asked us how much income tax does she need to pay. So your answer to part A is just 13,000. We stop there and we don't need to go any further. In part B here, we're asked to draw a graph to represent the amount of income tax that someone would have to pay for every income up to 60,000. Now this is actually quite straightforward, and we only need to do we only need to work out 1 or 2 of these simple ones. First of all, we know that if someone earns 50,000, they have to pay €13,000 in tax. So you could mark that one in straight away. Like, you already know one, that's the only point I want to make there. But what I want to hone in on is the 35,000 here. That's really important. Let's ignore this half of Lorna's income. Let's just imagine if someone only earned 35,000. If someone only earns 35,000, they have to pay 20% tax on that. If someone earns 30,000, they have to pay 20% tax. Someone earns 25,000, they have to pay 20% tax. Either way, no matter how much money you earn, from €0 to €35,000, you're paying 20% tax. So the amount of tax you pay increases at a steady rate, or it increases in a linear fashion. So I know that from the origin, where the graph starts, the whole way up to people earning €35,000, that's going to be a straight line. It's going to be a straight line the whole way up. I know that if someone earned €35,000, then they'd have to pay 20% tax on that. 20% of €35,000 is 7,000. So I know that if someone earned, let's ignore this 50,000 as well. For everyone who earns between €0 and €35,000, the income tax is going to be a straight line. It's going to be a straight line the whole way up to 7,000. So you can mark in straight away on your graph that if someone earns €35,000, they have to pay €7,000 in tax. And it's after that, it's no longer going to be have the same slope. Then there's going to be a change in the slope, because if someone earns more than €35,000, they have to pay more tax. So the amount of tax they're going to pay, so that line is going to get steeper. So the first thing we need to do is we can just graph this and represent everyone earning money between €0 and €35,000. So based on that information, in our graph, now obviously your graph should be more accurate than mine, you've got those lines. But in our graph, we know we're starting at 0, 0, and that from someone earning from between 0 and €35,000, the income tax is going to increase at the same rate. Everyone who earns between 0 and €35,000 pays 20% income tax. So that means it's just going up in a straight line up to the point where X is 35,000 and your income tax is 7,000. So it's just going up in a straight line, but after this point it's going to change because now people are starting to pay income tax at a rate of 40% rather than at a rate of 20%. So once I've graphed that, once I've done half of my graph, I can now worry about what happens to people who earn between 35,000 and 60,000 euro. Going from the 7,000, after you've paid 7,000 euro, from then on, for whatever you earn, you pay 40% tax on it. So that obviously is it's going to be linear as well, but it's going to be steeper because now you're paying twice as much income tax. The percentage is twice as much as it was. So the graph is going to become twice as steep. So you can work out that if someone earns 60,000 euro, the first 35,000 would be at 20%, which is 7,000. 60 minus 35 gives me 25. So the remaining 25,000, you would have to pay 40% tax on it. So 40% of 25,000 is 10,000. If I add those two together, I get 17,000. So I know that if someone earned 60,000 euro in this country, they'd have to pay 17,000 euro in tax. Now, so I can draw a straight line from where we were, where the point that we drew a minute ago, where if you earn 35,000 euro, you pay 7,000 euro in tax. But then the graph just gets a bit steeper, and then we can go linear in a linear fashion straight up to 17,000. So that if someone is earning 60,000 euro, they'd have to pay 17,000 euro in tax. So once we've identified that figure, we can just plot it. We can say that when someone earns 60,000, they pay 17,000 euro in income tax. So you're basically plotting the point 60,000, 17,000. It should be clear from your graph that from 0, 0, the whole way up to 35,000, people's income tax increases at a specific rate. But once we go above 35,000, it starts to increase at a faster rate. So the slope, it gets a little bit steeper. It should be obvious from your graph that there's a change in the slope there and that it turns at this point and gets steeper. Now in part C, we're asked to take into account what would happen to this graph if everyone got a 3,000 euro tax credit. And we're asked to go from 15,000 to 60,000. So to start this one off, so what we should do is work out how much tax would someone have to pay if they earned 15,000 euro and had a tax credit of 3,000 euro. So let's just work this one out. In this scenario, if you only earn 15,000 euro, you're only paying 20% tax. You don't have to pay the higher rate of tax because you're below the cutoff point. 20% of 15,000 is 3,000 euro. So that's actually the gross tax. The gross tax in this scenario is 3,000 euro. But now all of a sudden people have tax credits of 3,000. So the amount of tax, gross tax minus the tax credit in this case is 0. So in this scenario, if a person earned 15,000 euro, they don't have to pay any tax on it at all because their tax credit covers them. So we can now go back to the graph in part B. We can plot that point that if someone earns 15,000, the net tax is 0. So that's going to be a point along the x-axis. And then we can work from there and deduce what's going to happen to the rest of the graph. So in part B of this question, if someone had earned 15,000, they would have paid 3,000 euro in income tax. So roughly you would have had 15,000, 3,000. But now I know that if there's a 3,000 euro tax credit, someone who earns 15,000 doesn't have to pay any tax whatsoever. So basically the black line was the answer to part B, and the blue line now is our answer to part C. And basically everything is just 3,000 lower. If someone in part B, if they had earned 35,000, they would have had to pay 7,000 euro in tax. But now they have a tax credit of 3,000. So if someone earns 35,000 euro, they only have to pay 4,000 in tax. So basically you just move down the point to the point 35,000, 4,000. In the previous part of the question, if someone had earned 60,000 euro, they would have paid 17,000 euro in income tax. But now they have a 3,000 euro tax credit, so that person only has to pay 14,000 euro in tax. So we plot the point 60,000, 14,000. And once again then we just join up the 3 points. And it's obvious then from your graph that basically the blue line here is exactly the same as the black line, it's just lower. And it goes to this point and then changes and gets a little bit steeper and moves up to that point. So that's all that you needed for part C here. Okay, the last question we're going to look at here is 2017 paper 1 question 2. Now, in the first two parts of this question are incredibly straightforward. However, you need to really understand what's going on so that you can try the last part of the question. In A part 1, we're told that a shop buys a certain type of t-shirt for €25 and that they sell that t-shirt for €49. We're asked to work out the markup, and they've told us that the percentage markup is the profit divided by the cost price. So the first thing we need to do here is work out the profit. So they sell them for €49 and they bought them for €25. 49 minus 25 tells me that the shop makes €24 on each of these t-shirts. So the profit they make is €24. To work out the markup is the profit divided by the cost price. So it's 24 divided by 25 and multiplied by 100 over 1 in order to turn it into a percentage. So the percentage profit in this case is the percentage markup in this case is 96%. And in part 2, they've asked me to work out the margin to the nearest percent. And they've told me that the margin is the profit divided by the selling price, and to turn it into a percentage you multiply by 100 over 1. The profit is 24 and the selling price is 49. 24 over 49 multiplied by 100 over 1 to the nearest percent is 49%. Now we're going to have to use this theory to answer the next part of the question. What I want you to really hone in on here is where the 49 comes from. 49 is the selling price, and the selling price is made up of the cost price, the amount of money they spent to buy the t-shirt, plus the profit. They spent €25 to buy the t-shirt, and then they made a profit of €24, so 25 plus 24 makes up the selling price. And I think that's the key to understanding the next part of this question. Okay, part B now requires a lot of thinking. So let's just go through this one. In part B, we're told that for a certain pair of runners that this shop sells, the markup is 50%. And we're asked to use this information to find the percentage margin. So let's just think about this one in detail. I know that we've already calculated the markup for the t-shirt. And in part 1, to calculate the markup, it was the profit divided by the cost price. So I know that the profit divided by the cost price multiplied by 100 over 1 is equal to 50% in this scenario. Now obviously I want to get rid of the 100 over 1 and I don't want things as percentages. It's a lot easier here if we have it as a decimal. So this is an equation. You should think of this as an equation, and what we can do is divide both sides by 100. If I divide the left hand side by 100, well, that's the opposite of multiplying by 100, so this would actually just be cancelled. And if I divide the right hand side by 100, I can just write this as 0.5. That's it. Rather than having it as a percentage, I have it as a decimal. So I can say that 0.5 is just equal to the profit divided by the cost price. So for the runners, the profit divided by the cost price is 0.5. We should just view this as an equation. If we're viewing this as an equation, what I would try and do now is eliminate my fraction. I can say that P, the profit for these runners, is equal to 0.5 times the cost price. In other words, the profit is half of the cost price. So just think about the logic in that. If that means that if the company are making a profit of €20 on these runners, then the runners cost €40. So basically, that the profit is just half of the cost price means the company bought these runners for a tenner and now they're selling them for €20. Or they bought the runners for €50 and now they're selling them for €100. We could think of it like that. In this case though, what I'm going to do is I'm going to keep using, we'll call the profit P and we'll call the cost price C. Now I know the relationship between the profit and the cost price. Now we need to consider the margin. I've been asked to work out the margin. And in part 2 of this question, to get the margin as a percentage, the margin was the profit divided by the selling price. So now I need to consider this. So the profit, we're just referring to it as P. Now I want to work out, how do you come up with the selling price? In terms of the profit and the cost, where does the selling price come into play? Think of what I pointed out to you in part 2. The selling price is just the cost price plus the profit. So whatever the company paid for this, the cost price is C, and then the profit in this case, I'm just representing as P. So the margin, to calculate the margin, it's the profit divided by the selling price multiplied by 100 over 1. The Profit we're just representing as P, and I know that in order to come up with the selling price, it's just how much the runners cost the company to buy plus the amount of profit they're making. So it's just the cost price plus the profit. The reason I want to do this is because I can now just simplify this fraction. Remember, I'm not trying to find the profit or find the cost price. I just want to work out what this would be as a percentage. So I just need to get this as a fraction and try and simplify it. I know that the profit is half of the cost price, or else it's in other words, it's 0.5 times C. So everywhere that there's a P, I'm going to sub in 0.5 times C. So on the top of this fraction, I can say that the profit is just half of whatever the cost price was. On the bottom of the fraction, I already have 1C, and I can say that the profit here, P, is just 0.5 times whatever the cost price was. So all I'm doing there is everywhere there's a P, I'm subbing in a 0.5 times C. The reason that that's handy is because now I have a fraction with only one unknown. I only have C's in it. And we know from our algebra that having only one unknown is a lot easier than having two unknowns. So let's just continue on here. The top of this fraction, I can't simplify, it's just 0.5 times C. The bottom of the fraction, I have 1C plus 0.5 times C. 1 plus 0.5 gives me 1.5C. Now look at what's going to happen here. I have a C on the bottom and a C on the top, which are going to cancel each other out or divide into each other. Which means that without even finding the cost price or the profit, I've worked out that the margin is 0.5 over 1.5. And to get this as a percentage, we just multiply by 100 over 1. If you plug that into your calculator, 0.5 over 1.5 multiplied by 100 over 1, it tells you that the margin in this case must have been 33.3%, but to the nearest percentage is just 33%. So for that question, that one was quite tricky. Another way of doing it was at this stage, you could have pretended, like you could have made up actual figures for the cost price and the profit. You could have said, right, well, if the profit is €20, the cost price is this. You could have actually made up figures for it and tried to work it out like that. So if you're struggling to understand the way I'm doing it here, it might be worth your while to go back to this point and just say, okay, well, imagine that the cost of the runners was €20. Then that means the profit made was €20, and you can work through it like that. And either way, you should end up with the same answer. Okay, so the first new thing that we're going to look at today is currency exchange. What I want you to do is go back to the PDF that I printed out in last week's class, and if we scroll down, where we finished off last week was we finished off at compound interest. And directly after that are questions on currency exchange. So in question 1, there's 5 or 6 different questions that we can do on currency exchange. I'm going to go through part A, the first part of this question, and then I want you to follow that template and work through the rest of it. First of all, I want you to realize the way that exchange rates are written. If you're in Ireland and you walked into a bank, exchange rates will tell you that €1 is equivalent to whatever amount of pounds. €1 is equivalent to whatever amount of sterling. It'll always be €1 relative to the foreign currency. If you were in the United Kingdom, it would be the opposite. They would tell you that £1 is equivalent to 1 point whatever euro. It would be £1 is this many dollars and £1 is this many Australian dollars or whatever. So in the table we've been given, we've been told that pound sterling, that €1 to pound sterling, €1 is equivalent to 0.97 pounds sterling. That's the way that exchange rates work. So in part A of this question, we were asked to work out if you have £100, how many euros is that equivalent to? Now I want you to follow a very strict template to do each of these questions. If you follow this template, they're all incredibly straightforward. Clearly what we're talking about are euros and pounds. So the two currencies involved are euros and pounds. So what I would always tell students to do is set up something like this, where you have a column where every time you deal with euros, you're going to put it in here, and every time you deal with pounds, you're going to put it in here. So I have a heading basically just on the left-hand side and the right-hand side. The exchange rate that was given to me was that €1 is equivalent to 0.97 pounds. Now the reason I'm writing that again is because obviously you have to write it out again. Like, that's the one that was given in the question, but this is what I want you to write. And then in any exam question, they'll tell you if you have €50, how many pounds do you have? Or you have £100, how many euros do you have? So they'll give you another piece of information. In this case, they've told me that if I have £100 and I want to work out how many euros that's equivalent to. So what I would do is I'd label, right, well, this is 100 and I want to work out X. If I have £100, what is that equivalent to in euros? So I want you to always set your questions up like that. You write a heading with each of your currencies. You say €1 is equal to whatever amount of your other currency, and then they'll tell you the number of pounds or they'll tell you the number of euros. Now, what we can actually do now is just write both of these as fractions. I can now say that 1 over x is equal to 0.97 over 100. So that's the way I always get students to do it. You set it up like that and then just write them as two different fractions. And from here on out, we're just dealing with basic algebra. I have 1 over x equals 0.97 over 100. So let's actually just work through this. So obviously the first thing that I want to do is try to eliminate my fractions. If I wanted to eliminate the fraction on the right hand side, I would multiply both sides by 100. If I multiply both sides by 100, 100 multiplied by the right hand side will just give me 0.97. 100 multiplied by the left hand side will be 100 over x. Obviously now my goal needs to be to try and get rid of the fraction on the left hand side. And in order to do that, we're going to multiply both sides by x. If you multiply both sides by x, you get 100 is equal to 0.97 times x. Now you're allowed to do both of those steps in one line. I'm just dragging it out for you so that you fully understand what's going on. And now in order to get x on its own, you would divide both sides by 0.97. If I divide both sides by 0.97, I'll end up with x is equal to 100 divided by 0.97. And if you plug that into your calculator, you'll work out that x is equal to €103.09. So if the exchange rate is €1 is equivalent to 0.97 pounds, then you'll end up with £100 is obviously equivalent to 103.09 euros. Now that template you can follow for every single one of these currency exchange questions. So I want you to just maybe watch this again if you're not 100% on it, and then I want you to pause this video and I want you to answer the rest of question 1 and then watch my solutions on it. Okay, in part B, we were asked to convert 10 Kuwait dinar into sterling. And from the exchange rates given, I know that €1 is equivalent to 3.11 Kuwait dinar, and that €1 is equivalent to 0.97 sterling. So obviously, if they're both equal to €1, that means that 3.11 Kuwait dinar is equivalent to 0.97 sterling. And now if we just set up the question the exact same way as we did the previous one, it'll be handy enough. I've been asked to convert 10 Kuwait dinar into sterling. So obviously that means that I know that this is going to be a 10. And I need to work out what is the equivalent amount of sterling. So now that I've set this up, I can just write them as fractions. I can just ignore this table and write it as a fraction. 3.11 over 10 is obviously equivalent to 0.97 over x. And now my goal needs to be to eliminate the fraction. So in order to eliminate the fraction on the right hand side, I would multiply both sides by x. If I multiply the left hand side by x, I'll get 3.11x divided by 10. If I multiply the right hand side by x, I'll get 0.97. What I would then do is multiply both sides by 10 in order to eliminate the fraction on the left hand side. If you multiply the left hand side by 10, you just get 3.11x. If you multiply the right hand side by 10, you get 9.7. Now my goal needs to be to get x on its own, and in order to do that, you're going to divide both sides by the coefficient of x, or in other words, divide both sides by 3.11. If you divide the left hand side by 3.11, you'll get x. If you divide the right hand side by 3.11, you'll get 9.7 divided by 3.11. Now I can just plug this into my calculator and work out the amount of sterling that is equivalent to 10 Kuwait dinar. So when you plug this into your calculator, obviously when we're dealing with money, we always round to 2 decimal places because we go to cents or we go to pence. So in this case, if you plug it into your calculator, you get x equals 3.12. I know that based on this exchange rate, 10 Kuwait dinar is equivalent to 3.12 pounds. Okay, for part C here, we were asked to convert €5,000 into dollars. And according to the exchange rate, €1 is equivalent to $1.4045. And so we set it up like this. We have euros on the left, dollars on the right. €1 is equivalent to this many dollars. I want to know if I have €5,000, how many dollars would I have? So once you've set that up, you're allowing yourself to write these as fractions. I can say that 1 over 5,000 is equal to 1.4045 over x. And then what I decided to do at this stage was eliminate the fraction on the right hand side by multiplying both sides by x, in which case I get x over 5,000 is equal to this figure. Then I decided to eliminate the fraction on the left hand side by multiplying both sides by 5,000, in which case I get x times 1.4045 times 5,000. If you plug that into your calculator, x works out as $7,022.50. So if I went into the bank with this exchange rate, if I went in with €5,000, I get this many dollars. Okay, so let's have a look at part D now. In part D, we were asked to convert 600 Cayman Island dollars into euros. And according to the exchange rate, €1 is equivalent to 1.07 Cayman Island dollars. So you should write out two columns like this, one of your currencies on the left, one of your currencies on the right. It doesn't matter which is on the left or which is on the right. You write out your exchange rate, which is €1 to $1.07, and then I know that I have $600, so how many euros is that equivalent to? At this stage, I can write this as a fraction. I can say that 1.07 over 600 equals 1 over x. And in order to eliminate the fraction on the right hand side, I would multiply both sides by x. And I ended up with an x on the top on the left. And then in order to eliminate the fraction on the left, I multiply both sides by 600 and I get 1.07x equals 600. And then in order to get x on its own, I divide both sides by the number in front of x. So x must be 600 over 1.07, which if you plug into your calculator to two decimal places, it tells me that 600 Cayman Island dollars, based on this exchange rate, is equivalent to 560.75 euros. Okay, the last one I asked you to do here was to convert €75.64 into Bahrain dinar. Now, according to the exchange rate, €1 is equivalent to 2.37 Bahrain dinar. So if I plug in 75.64 in my euros, the only unknown is my x here. And once I've set that up, the exact same, notice there that we've done literally the exact same setup in every single question, anything to do with exchange rates, I think this is your man. Once we have this, you can just write them as fractions. I can say that 2.37 over x equals 1 over 75.64. And in order to eliminate the fraction on the right hand side, I decided to multiply both sides by the denominator of the right hand side. If you multiply the right hand side by 75.64, you get 1. If you multiply the left hand side by it, it just goes on the top of the fraction. What I then decided to do was to eliminate the fraction on the left by multiplying both sides by x. If you multiply the right hand side by x, you get x. If you multiply the left hand side by x, the fraction is gone. And if you multiply the top 2.37 by 75.64, you get 179.27. So that's your final answer for part E. Now, the next question is slightly different, but nonetheless, I want you to try question 2 before you watch me going through it and see if you can figure it out. Okay, we're only doing one other question on currency exchange, but in this question, we're taking into account something else. Obviously, if you went into a bank to exchange, if you went into a bank with €100 and asked them for dollars or pounds or another currency, there's a built-in charge. Like the bank charge you for the service of allowing you to change your money. So in this question, we have to account for the commission that a bank charges. In this question, we're told that a tourist exchanged $2,500 for euro in an Irish bank, and the bank charged a commission for the transaction. So they exchange the money and then take off 2% or take off 3% for themselves. We're told that the exchange rate was €1 is equivalent to $1.34, and the tourist received €1,800.42. We've been asked to find the percentage commission charged by the bank correct to two decimal places. So this tourist received €1,800.42. But obviously, the tourist should have received more than that. The tourist, the bank did the exchange rate and then they took 2% and took it away, or took 1% and took it away as their commission. So what I need to do, first of all, is figure out how much money should the tourist have gotten. If they hadn't charged any commission whatsoever, how much should the tourist have gotten based on this exchange rate? So that's the first thing I'll do, and once I know that, I'll be able to then work out the percentage commission. So in this case, it's the exact same as the 5 questions we did in part 1, the 5 bits we did in part 1. I've got a column for euros and I'm going to have a column for dollars. And I'm going to start off by writing in the exchange rate. I know that €1 is equivalent to $1.34. If this tourist walked into the bank with $2,500, I want to work out how many euros was the tourist entitled to if the bank hadn't been charging a commission. This is going to be straightforward enough because I can just say that 1 divided by x is equal to 1.34 divided by 2,500. Now, I could multiply both sides by 2,500 in order to get rid of the fraction on the right. And I could say that 2,500 divided by x is equal to 1.34. And then in order to eliminate the fraction on the left-hand side, I will multiply both sides by x. And I can say that 2,500 is equal to 1.34 times x. And in order to get x on its own, I'm going to divide both sides by 1.34. That allows me to say that x is equal to 2,500 divided by 1.34. And if I plug this into my calculator, I'll be able to work out the amount of money the tourist would have received if there had been no commission whatsoever. So if we plug this into our calculator, x works out as €1,865.67. That's how much the tourist should have gotten based on this exchange rate. But the tourist only actually received €1,800.42. So now I can work out the percentage commission charged. So the first thing I need to do is work out how much the bank actually charged the tourist. The tourist should have received €1,865.67, but actually only received €1,800.42, which means that the bank charged the tourist €65.25 for their service. Now I need to work out what was the percentage commission. So I need to get 65.25 as a percentage of what the tourist should have received. The tourist should have received this. So I want to work out what percentage of what she should have received is the figure that they took away. So it's 65,025 as a percentage of 1865.67. And remember, to turn things into percentages, you multiply by 100 over 1. Now if you plug this into your calculator, the commission or the percentage commission works out as 3.5%. The bank should have given her this much money, but they got 3.5% of it and took it away. Now for the next few minutes, I want to go through questions on distance, speed and time. You should all know this triangle. I'm sure you're all familiar with it. The relationship between distance, speed and time is represented by this triangle. If you're looking for speed, you would cover speed, and speed is distance divided by time. If you're looking for time, you cover time, and time is distance divided by speed. And if you're looking for the distance, you cover d, and it's speed multiplied by time. So whichever one you're looking for, you cover it, and that tells you the other two that you need in order to find your distance, your speed, or your time. Okay, now when we're using this triangle, we want to have our time as a decimal. So usually in questions, they tell you time in hours and minutes. But when you're using this triangle, you can't use hours and minutes. For time, you need to be subbing in time as a decimal. So in the first question here, we're going to start converting hours and minutes into 1.2 hours or 1.6. We're basically turning it into a decimal. In order to do it, well, 1 hour, obviously that's going to be 1. I don't care, the number of hours I don't need to change. It's the minutes that I do need to change. In order to convert minutes into a decimal, you divide it by 60. So you would just take 15 divided by 60. And if you plug that into your calculator and press the button that allows you to change it to a decimal, it tells you that 15 divided by 60 is 0.25. So that means that 1 hour and 15 minutes is 1.25 hours. So if you had an exam question that told you the time it takes to get from this place to this place is 1 hour and 15 minutes, if you were using this formula to find the speed or the distance, you would have to take that as 1.25 hours. So it's really important that you're able to convert from hours and minutes into 1 point something hours or 2 point something hours. So I want you to just pause the video now, go through the 3 questions there in the booklet, and then just watch my solution. So this question is relatively straightforward to go through. If you have 1 hour and 30 minutes and I ask you to convert that to a decimal, you would take 30 and divide it by 60. The 30, the number of minutes, over 60 is 0.5. In other words, 30 minutes is 0.5 of an hour, it's half of an hour. And 1 hour and 30 minutes would be 1.5 hours. For 1 hour and 6 minutes, 6 over 60 is 0.1. Or in other words, 1/10. Obviously 6 minutes is 1/10 of 60 minutes. So 1 hour and 6 minutes is equivalent to 1.1 hours. And then if you have 1 hour and 57 minutes, you take the 57 and divide it by 60, which gives you 0.95. Which tells me that 1 hour and 57 minutes is 1.95 hours. Okay, so in question 1, we're taking the minutes, we're dividing it by 60 in order to convert it into a decimal. In question 2, we're doing the opposite. Usually, if you're doing one of these distance, speed and time questions, often your answer will work out as, let's say, 1.4 hours. But the question will have asked you to leave your answer in hours and minutes. So we need to be able to do the opposite of what we've been doing previously. This time we're going to take the 0.4, the decimal, and we're going to multiply it by 60. So in question 1 we were dividing by 60, now we're just doing the opposite. We're going to take the decimal, the 0.4, and we're going to multiply it by 60. 0.4 multiplied by 60 is 24. That tells me that 0.4 of an hour is 24 minutes. And that tells me that 1.4 hours is in fact 1 hour and 24 minutes. So what I want you to do is I want you to go through the 3 questions here in question 2, and in each case take the decimal, multiply it by 60 to convert to hours and minutes. Okay, so once again this was relatively straightforward. If I have 1.25 hours, you take the 0.25, multiply it by 60 and you get 15. That tells me that 1.25 hours is in fact 1 hour and 15 minutes. 0.9 multiplied by 60 is 54. That tells me that 1.9 hours is actually 1 hour and 54 minutes. 0.75 by 60 is 45, which tells me that 1.75 hours is actually 1 hour and 45 minutes. And then 0.65 by 60 is 39, which tells me that 1.65 hours is 1 hour and 39 minutes. Now what I want you to do is I want you to have a look at question 3. Try it yourself first, see if you're able to do it, and if not, then watch my solutions on it, and I'm going to go through it now. Okay, if we have a look at question 3, this is the way the questions are likely to come up in an exam. In question 3, it says a bus travels for 2.5 hours at an average speed of 90 kilometers per hour, and then a further hour at a speed of 70 kilometers per hour. We're asked to find the total distance travelled. This is a classic case where we need to use our triangle, our distance, speed, time triangle. And we've been asked to find the distance. According to this triangle, to get distance, it's speed multiplied by time. However, we need to view this as 2 separate journeys. In this scenario, for the first 2.5 hours, he's at a certain speed, and then for the last hour, he's at a different speed. If we're going at 2 different speeds, we need to take this as 2 different scenarios. Find the distance travelled at 90 kilometers an hour, and then find the distance travelled at 70 kilometers an hour and add them together. I would always tell my students in these questions that you write out your D, your S and your T, and you write in the information that you know. For the first segment of this journey, I know that the speed he is travelling at is 90 kilometers per hour. And I know the length of time he spends travelling at 90 kilometers per hour is 2.5. So I know S and I know T, which means I can use this triangle to find D, the distance travelled. I would always get students to just set that up first. Now let's also do it for the second segment of the journey. In the second segment of the journey, I know that the speed he's travelling at is 70 kilometers per hour. And the length of time that he travels at that speed is 1 hour. So I know S and I know T. Once again, I can use this triangle to get the distance D. So let's just work each one out individually. According to this triangle, if you're looking for D, you just cover your D. That means it's speed multiplied by time. So in the first segment of the journey, the distance travelled will be 90, the speed, multiplied by 2.5, the time. And if you plug that into your calculator, that tells me that the distance travelled at that speed is 225 kilometers. I know that it's in kilometers because it told me that this is 90 kilometers per hour. So the distance travelled at the original speed is 225 kilometers. To work out the distance travelled at the other speed, once again it's speed multiplied by time. So distance in this case is speed, which is 70, multiplied by time, which is 1. Obviously 70 multiplied by 1 is just 70 kilometers. So I know that he originally went 225 kilometers at 90 kilometers an hour and then 70 kilometers at this speed. I was asked to find the total distance traveled. The total distance traveled will be just 225 plus 70. So the total distance traveled in this scenario is 295 kilometers. And that's your final answer for the first part of this question. Then the second part of this question is very straightforward. It says find the percentage of the total distance spent travelling at 70 kilometers per hour to 2 decimal places. From what we did in part 1, we know that he travelled 70 kilometers at 70 kilometers per hour. That was the distance travelled at 70 kilometers per hour. And we know that the total distance travelled is 295 kilometers. And I've been asked to get that as a percentage. So the distance travelled at the second speed as a percentage of the total distance. So I multiply by 100 over 1. And in the notes here it says to leave it to 2 decimal places. So your answer is 23.73%. In part 3 we were asked to find the total time taken. The total time taken is just he spent 2.5 hours travelling at 90 kilometers an hour and then another hour travelling at 70 kilometers an hour. So it's just 2.5 plus 1 gives me 3.5 hours or 3 hours and 30 minutes. The last part of this question asks you to find the average speed of the bus for the whole journey to 2 decimal places. Well, in the first part of the question, we worked out that the total journey is 295 kilometers. And in the third part of the question, we worked out that the total time is 3.5 hours. If I know the total distance and the total time, I can work out what the average speed was over this 3.5 hour period. Once again, we're just going to use the triangle d over s multiplied by t. In this case, I'm trying to find the speed. If I'm trying to find the speed, I ignore the speed, and I can clearly see that to work out the speed, it is distance divided by time. In this scenario, the distance is 295 and the time is 3.5 hours. So if I just plug this into my calculator, I'll be able to get the average speed to 2 decimal places. If you plug it into your calculator here, it works out as 84.29. So that tells me that the average speed of this bus over the 3.5 hour period must have been 84.29 kilometers per hour. Okay, the only other thing I want to do in this class is I want to talk to you about ratios. Now I'm going to do the first question here and then I want you to pause the video and go through the other 2 questions and then watch my solutions on it. In the first question here, it's straightforward enough. I'm simply asking you to divide €960 among 3 people in a ratio of 5 is to 2 is to 1. Now in a scenario like this, the first thing you need to do is work out how many different parts there are here in the ratio. What I mean by that is to work out the number of parts, you just add up 5, 2 and 1. I need to divide €960 in a ratio of 5 is to 2 is to 1, and 5 plus 2 plus 1 is equal to 8. So that tells me the first thing I should do is divide €960 into eighths. What is 1/8 of €960? Because this guy, the first person is going to get 5 eighths, the second person is going to get 4 eighths, and the third person is going to get 1/8 of the total amount. So to work out what 1/8 is, it's €960 divided by 8. €960 divided by 8 gives me €120. That tells me that 1/8 of this amount of money is €120. And now I can relatively easily divide that in a ratio of 5 is to 2 is to 1. I know the first person gets 5 eighths, the second person gets 2 eighths, the third person gets 1/8. So clearly the third person is actually getting 1/8, which is €120. The second person is getting 2 eighths. 120 multiplied by 2 is 240. So this person is going to get €240. Whereas the first person, the person getting 5 here, 5 multiplied by 120 is €600. The first person gets €600, the second one gets €240, the third one gets €120. And in a question like this, just to double check that you haven't made a mistake, you should add up those 3 numbers, 600, 240 and 120, and they're going to add up to €960. So what I want you to do is pause the video now, and I want you to just try question 2 and question 3. In question 2, we were asked to divide €252 between Sarah and John in the ratio of 3 is to 1. So the first thing I would do is I'd just say 3 plus 1 is 4. I have to divide this money into 4 into 4. So €252 divided by 4 is €63. And I know that Sarah is going to get 3/4 of this money. John is going to get 1/4 of this money. We've worked out that 1/4 of the money is actually €63. So John gets €63. Whereas Sarah gets 3/4 of the money. So €63 multiplied by 3 gives me €189. Sarah obviously gets €189 while John gets €63. Once again, you should realise that when you add these two numbers together, they add to 252. And this number is 3 times as big as this number. Sarah's getting 3 times as much money as John is getting. Okay, and the last question I'm going to do in this video is question 3 here on ratios. We're told that in a school, the ratio of boys to girls is 5:4. If there are 525 boys, how many students are in the school? So in this case, you have to realise that there's 5, the number of boys to girls is 5:4. So we could divide this into 9 different parts. 5/9 of the students are boys, 4/9 of the students are girls. And I know that there are 525 boys. So I know that 5/9 of the total population of this school is 525. Because I know that the 5 and 4 add up to 9, and 5 of the 9 of them are boys. So 5/9 of them are boys. If I know 5/9 of the total population of the school, I can obviously just work out 9/9 of the total population of the school. That will tell me how many students are in the school. 5/9 of the population is 525. So what I would do next is I would divide both sides by 5. That would tell me that 1/9 of the total population is 105. And what I would do then, if I know 1/9 is 105, obviously I want to get 9/9, so I want to multiply both sides by 9. If you multiply both sides by 9, you could say that 9/9, or in other words, the total population of this school is 945. So essentially what you needed to do is take this figure, divide it by 5 and multiply it by 9. So your final answer for that one is 945. So that's all that I wanted to do. We just wrapped up a few little bits and pieces at the end of this booklet. What I want to do now is I'm going to give you a couple of exam questions to try for next week. So for homework, I want you to try 2017 Paper 1 Question 3 and Question 4. And at the start of class next week, I'm going to go through that one first.